So inverse DFT sequence, that's all calculated direct method and transformation method. So inverse DFT, so this is a formula for inverse DFT. So only different is 1 by n is in before the equation and e power j. Find out DFT of the equation x of k. So this is an example. So they given x of k. So previously direct DFT, that is equation x of n. Here they given x of k. So x of k value is there. So total count is n. So that is n is equal to 4. So 1, 2, 3, 4. Okay. Then the formula of inverse DFT. So this is a x of n. So just apply n value for 4 on x of k e power minus j n k divided. Then this is take it. This is the equation is the first one. Then put the k value. You know what is k value? So n is equal to 4 means it is 4 minus 1 is equal to 3 n minus 1. Okay, so n is equal to 4. So for 4 minus 1 is equal to 3. So the n value started from 0 to 3. Similarly, k value, small k value started from 0 to 3. So you just apply first k value in normal DFT method. This is inverse. In ordinary DFT method, first you have to put it n value. After that, x of n value, and finally you will be put it k value. And here you have to put it k value because the problem also they given k. What is k? It's a frequency. N means time domain. K means frequency domain. So k value is there. So x of n. So the put the formula 1 by 4. So you just what is the same? This is expand the equation. So 0 to 3. So k value is 0 to 3. So you just wherever the k is there, just put the value 0, 1, 2, 3, and just to cancel it the 2, 4. So like that you have to simplify the equation. And we have also, we already know this is x of 0, x of 1, x of 2, x of 3. This is already we have in the input. So just apply the x of n values and you got the equation like that. Okay, so this is x of 0, x of see that x of 0 is 2. So this is 2. Then the x of 1 is 1 minus j. So 1 minus j. So 1 minus j. Okay, so the you have to flow like that. Then you have to say, wherever the 0 is there, this node, you just ignore it, cancel it. E power 0 means it is 1, so that is 2. Then put n value 0, 1, 2, 3. Then n is equal to 0. Then what's the value of this? Then finally you will be get it 1. If n is equal to 1, and just apply the equation, same equation, you just apply n is equal to 1 and simplify it, and you got the value 1. Then take it same equation and n is equal to 2. Then simplify it and you got the value 0. Then n is equal to 3 and simplify it, you got the value is 0. So it's very simple only because 2 1 plus j e power j to j by 2, just put the calculator. This is, you know, that pi by 2. So plus pi by 2 means it's a cos pi by 2 j sin pi by 2. So the value of the calculator, you just put it, you will get it j. So similarly, uh, so you have to apply in the calculator e power j 3 pi by 2. So 3 pi by 2 means cos 3 pi by 2 plus j sin 3 pi by 2. You just put the calculator, you get the value minus j. So directly you just apply in the calculator and you will get the values. So this is the value, and finally you got the value as 4. So 4 divided by 4 is 1. So this is the way you have to calculate everything. And finally just write the answer x of n. And in direct form they given x of n. Finally you write it x of k. And here they given x of k, and finally you have to write it x of n in inverse DFT. Okay, this is the answer. Okay. So similarly same, that's another example. So take it this example. So write the formula. So n is equal to 4. So n is equal to 0 to 3. Small k is 0 to 3. So this is a formula. So apply the n value, and first you have to put the k values, and then x of 0, 1, 2, 3 values, and then you have to put it x of n values, and put n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, and finally write the values. So this is the way you have to write it. Inverse DFT direct method. Thank you.